Hey there, welcome back to another video, and in this video we are gonna see the update rule for the logistic regression. And what update rule is basically, as we did in the linear regression, that we used the gradient of the, or no, not the gradient, we used the derivative of the error function to update our theta. Similarly, in logistic regression we have to find the derivative for our cost function, that is log likelihood, so that we can use that derivative to update our theta so that we can have a good output. So without wasting any more time, let's get into the video. Okay guys, so this is the update rule basically, and what we are doing is that we are finding the theta, or we are finding the derivative. Yeah, so we are finding the derivative for our log likelihood. So this was our log likelihood function, or this was our cost function that we uh, derived in the last part. So what we are going to do is we are going to apply the derivation different we are going to apply the differentiation here, and after applying the differentiation it is going to generate a result like this. Okay, so how it is going to generate it, let me just explain you. First of all, you should know that you can write as theta of x into, you can also write this as g of theta transpose x. These are the same things, it doesn't matter, so I have written here. So what I have done here is I have used this. So for the log, on the differentiation of log is this, that y divided by it, this value is going to be coming here. So that's why that what happened here, and I have used this notation. Similarly, in this case I have used 1 minus y divided by, and uh, I have moved this value here. Okay, so this is basic, but what is happening beside this? So what is happening beside this is that we are also going to get the derivative for this, and we are also going to get the derivative for this because of the chain rule. Okay, so because of that chain rule, what it is going to do, what I am doing here basically is that I have take a common for that. I have got it outside, because we had these values like the g dash theta transpose x, and we also had 1 minus g dash theta transpose x, or we had this basically, not 1, we had only this. So what happened is that I took a common out, and we had this minus as here, we had this negative as here. Okay, so we got this value out. After that, what happened is that we have to apply the chain rule also here. So for that we are doing this, and this is the step here. Now let's move on to the next step. What I'm going to do is I'm going to take an LCM of this, and after doing that, what it is going to do, it is going to generate a line like this. You can just do this very simple maths calculation, it is not a big deal, I am not going to explain it. And yeah, so I have to explain the outer part. So what it is going to do is basically so this is a sigmoid function, and the derivative of this sigmoid function is going to be like this. So as I have written, so as I have written here, the derivative of a sigmoid function is sigmoid function multiplied by 1 minus sigmoid function. Okay, so what I have done here is the derivative of this sigmoid function is sigmoid function multiplied by 1 minus sigmoid function, which is going to cancel out by this, and we will left with xj, or you can say x for now. And why do we will be why do we left with xj? Because we are also gonna use the differentiation on this part. So uh, theta t, let's take theta 0 x0, theta 1 x1, theta 2 x2. So if we are doing the differentiation on the basis of, let's take theta 1, so every other value is going to be 0, and the derivative of this is going to be x1. So this one I can change with this or this, so that's why I'm taking it as xj. So I hope that it is clear how it is going on right now. Okay, now in the next thing what I'm going to do is, so now I'm going to multiply them together, that we have done here. So yi minus yi into sigmoid function plus y into sigmoid function minus g, or basically you can say directly this is a sigmoid function. Okay, so now these values are same, so I can just cancel them out, and this is also going to be yi. Okay, so we are going to cancel them out. Now what is going to happen is that we are left with this part. So yi minus g, basically sigmoid function, or you can say this sigmoid function is going to predict our output, so you can say y hat, and xj multiplied with it. Now this value, this sigmoid value, can again be represented like this, which is going again, this is our sigmoid function, so this is going to be predicting our value. So y, so basically our derivative is like y minus y hat into xj. Now if you have seen my linear regression video, then you will know that, then you should know that this is the same output that we got with the MSE. So when we find the derivative of when we found the derivative of the mean squared error, we had the same output like this, but the difference here is that we have this function different. And also the reason that we have the same kind of output is that we are thinking that okay, so our output belongs to the normal distribution, which might not be the case always, but for this video I'm going to stick it to that. But yeah, so this is why it is looking like that we have used MSE, but still you cannot use MSE here, because there could be some cases in which MSE and log likelihood won't make a difference, because you can use them alternatively. It is not going to be a big deal in logistic regression, but there will be some cases in which it is going to give a wrong value, and you won't be able to identify what is going on wrong, what is going wrong with your algorithm. So it is better to use directly log likelihood, and although the result is same, it is not the result is same, the result is similar, because we have this value as different. Last time this was a different formula, and this time we have a different formula. So I hope that it is clear, and I've tried my best, because it is very difficult to explain something when there is no cross questioning. I have already said it once before. So what you can do is, basically you can watch this video 2-3 times, and you should also try to drive this by your hand, with a pen or with a pen paper. So you have to write, you should write this down, so you will understand that better. I also had to spend, like in linear regression, logistic regression, in all of these things, I have to spend a week at least to understand all of these, so that I can explain it to you guys. So I'm saying it again, if you didn't understand it, then please go and watch this video at least twice. And even if you then don't understand this, then please comment in the comment box. I will reply to you. I will uh, clear your explanation or your queries. I will clear your queries. So thank you for watching this video, and I'll see you next time.